Hi, my name is Stephen Power. This is my final year project. It's a passwordless authentication system that uses FIDO2 and WebAuthn. The system eliminates passwords entirely using public key cryptography. So this is where the private key never leaves the user's device, and only the public key is ever stored on the server. So let me show you how it works. So I will enter a username. So let's say demo user. Now I'll register with the passkey. So as you can see, my Mac ID shows the Touch ID. So how this works is that this calls the register start endpoint on the Flask backend, which creates a public key credentials user entity. And also calls the server register begin function that I've got from Python FIDO2 library. So what this means is that the server generates a cryptographic challenge and sends it back to JSON. So now I'll just use my fingerprint to authenticate. Yep. So you can see authentication is successful. So yeah, the browser calls navigator credentials create, which is a function received from the simple WebAuthns start registration function. So how this works is that the Touch ID generates a key pair in the device's secure enclave and is signed with a cryptographic challenge. So how this works is that the signed response goes to the register finish endpoint and then verifies the attestation and stores the public key in PostgreSQL database. And you can also see that there's 8 recovery codes that appear. So when you first register a new account, the backend generates these 8 recovery codes, which is done using the Python secret module. So each code is hashed using SHA-256 before being stored in the recovery codes table. So the plain text codes are shown here once, but they're never stored as plain text. So I'll just save these. So yeah, now I'll give you a quick show of how this works in the PostgreSQL backend. So we just get a function that I have here, run that. So as you can see, the username is stored here, which you can see, and there's also a timestamp of when it's created. So there's no password hashes. I have another command here I'll show you. So you can see that there's credentials table stores the public key, credential ID, authenticator type, and the trust level from the attestation format. So you see there's no private key column or there's no passwords being stored. So if this database is breached, the attacker actually gets nothing that's usable. So in terms of security, that's good. And I have another command I'll run here. So you can see I only have 3 of the 8 codes listed right now, but each of the codes are stored as SHA-256 hashes. So the original codes cannot be reversed from these hashes, and they're not stored as plain text. So next I'll show you the authentication flow. I go back to my code. So here is my registration UI, which I just showed you. So now I'm going to log in with this username. Use my fingerprint to authenticate, and yeah, I'm in. So the front end sends this username to the login start endpoint in the Flask backend. It looks up the credentials for the user in PostgreSQL and calls the server authenticate begin function, which is where the browser signs the challenge with the private key using the start authentication function. So the backend verifies the signature against the store public key using the server authenticate complete. So that's how it works behind the scenes. So now I'll just go. This is the passkey manager actually. So when you register and then you authenticate, this is where the users come to, so they can manage their passkeys. You can see there's a count of the amount of passkeys this user has. A few tips here. I can actually add a new passkey. I can add a security key to this account as well. I can refresh the passkeys. There's an admin view as well, and I can go back to my login. Here is where you see, the credential ID, when it was registered, and actions such as delete. You can see right now that I actually can't delete this credential because I have it set that there has to be a minimum of 1 credential per account to ensure that there's no accidental lockouts and so on. So if there was more credentials, I'll just show you now. I'll just add another one. So you can see now I'm able to delete because there's 2. So this is a single, make sure that there's always a single passkey on the account to ensure that you're never actually locked out. Next, I will show you the user nameless login. So how this works is that, like, even better, without having to enter a password, I don't actually have to enter a username either. So if I just click in log in with a passkey, you can see these are all the different passkeys that were registered before. So here I'll just select the one I just created, use my fingerprint to authenticate, and I'm back into my account. You can see here's the toast notification that appears when you successfully authenticate. So how this works is that this hits the login start user nameless endpoint in the backend, and this passes an empty credentials array to authenticator begin. So this is where the browser shows all the discoverable credentials which you've just seen for this origin. So after authentication, the user handle from the response is base64 decoded to recover the username. So there's no username input actually required for this to work. So next I'll show you the conditional UI. So similar to passwords, so there's an autofill experience that you would have seen with passwords. So I've also implemented this to work with passkeys. So I'll show you how that works. So I click in the input field, and you can see there's all the passkeys that appear that you can choose from without having to enter a username. So how this works is that the username input has a autocomplete WebAuthn set. So on page load, a useEffect hook calls the start authentication with user browser autofill. So this then triggers the browser to show all the different passkey suggestions, which you can see here. So just like password autofill, which you would have seen before. So now I'll just go back to my account again, use my fingerprint, and I will be able to access the account, which you can see. So that's conditional UI. Next, I'll show you cross-device authentication. So go back here. Here I have a button, all authenticator types. So I click this, create user. So phone user, all authenticator types. You see by default it shows the Touch ID, but actually cancel that, and a load of different options appear here. For this, I'm going to use my phone, so a QR code will appear. So now I just get my phone out and I take a photo, or I scan that QR code using my camera, so I can save the passkey on my phone right now, and it should start to work once I add the passkey and use my Face ID on my phone. And yeah, I registered this account successfully, and then I can also log in with a passkey. I can use my phone again, so get the camera out and I can sign in with the passkey that I just created on my phone, and I'll be able to authenticate successfully, as you can see. There we go. So now I'm signed into this account with the use of my phone, as the passkey is saved on my phone's secure enclave. So yeah, that's the cross-device authentication. So the phone acts as a roaming authenticator. The key pair is generated on the phone and signed, and the signed attestation is sent back to my Mac's browser, and then this is also forwarded to the register finish endpoint. So that is cross-device authentication in a nutshell. Next, I will go on to admin and revocation. So if I go to my admin screen here, you can see here are all the different users. So how this works is that I wanted to implement an admin dashboard, which queries all of these users from PostgreSQL with their credentials, registration timestamps. I can manage them, and I can also revoke these users. So I'll just revoke the phone user I just created. It'll make sure I want to do this. And as you can see in the live authentication logs, this user has been deleted. I'll just refresh the users and you can see it is gone. A quick way to see that this worked, if I go back here and I use that same name, phone user, and I try to log in with this username, it won't work because this previously registered user no longer exists in the PostgreSQL database. So that is admin revocation, or admin screen. Next, I'll go on to revocation. So I previously registered a user. So if I go to the recover account screen, So here you see there's a few recovery steps, just the format of how to enter the codes. So in the event that a user loses their device or can't access, as you've seen, there was 8 recovery codes that were generated. And these recovery codes are important, making sure that that user can access their account in the event of device loss. So I'll just give you a run through of how this works. Recovery. And then I get my codes, which I have up here saved already. And I'll enter and recover account. Maybe I have it named wrong. Demo recover account. I get prompted Touch ID again, and you get a toast or a message here that says it was successful. I get rerouted back to the login screen. So when I go and log in again, log in my username, Touch ID, and I should be able to access the account. And as you can see, the new credential is created. So this is a recovery flow in a nutshell. How this works is that the recovery endpoint hashes the submitted code with the SHA-256 and compares it against the recovery codes table. And so if it matches, the code record is then deleted from the database. So for single-use enforcement, so this means that this recovery code that I used just now can never be used again. So now I'll have seven remaining attempts to recover an account. So yeah, that is my my system in a nutshell. I think that's everything I've covered, and yeah, thanks for watching.